All right. So today we're talking about graphing cosine, which is the 714 lesson. Remember, we flip-flopped last class and this class, so you're going to be talking about how to graph cosine, which will be very similar to how we graphed sine. Now, I warn you in advance, Miles is here, so he may end up squawking at some point, and we're just going to kind of keep going. So 745 asks you to learn the coordinates, or to find the coordinates of point P on our unit circle here. So when we're talking about that coordinate point, remember, we're talking about an x, y coordinate plane. And if I'm thinking about point P, there's the 34, this is 1, and I want to get there, this side would represent the y part of the coordinate, and this side would represent the x part of the coordinate. So I'm going to have to solve for each of those individually. So let's say I want to do x first. So thinking about my sine, cosine, and tangent, what I know from back in the day, I would need to do cosine to find x, because that would be the adjacent over the hypotenuse. So cosine of 34 would give me x over 1. And then from there, I'm going to have to solve for x, so I would need to get x by itself by multiplying by 1 on each side, which we know isn't going to do anything. So we would end up with cosine of 34 equals x. So now I can type that into my calculator and get out an answer. So cosine of 34, and I get 0.829 is x. Now, in order to find y, I have a few options. I could go through and do Pythagorean theorem and solve for y, or I could think about it in terms of just the right triangle and say, since I want to find the opposite side and I have the hypotenuse, it would be sine of 34 is y over 1. Multiplying by 1 on both sides again, which would mean I would be doing sine of 34 in my calculator, which gives me 0.559 equals my y value. Now, if I wanted to check, since I used trigonometry to figure this out, I'm going to use Pythagorean theorem just to show you that it would have worked as well. So since I know, or since I think x is going to be 0.829, that would be 0.829 squared plus 0.559 squared, and that should work out to be 1 squared. So I'm going to test that theory just to make 100% sure. Cosine 34. And it does actually work. So both of these would have worked, and if I were to go from here and do Pythagorean theorem, it would have worked as well. So the coordinate point of this particular spot would be 0.829, 0.559. Now, this is leading us towards where we're headed for today, which basically the idea that we ended with 2 classes ago was that y is going to be the height or your sine, and that x is going to be the width of your cosine or your cosine. So let's get into it. For 76, they're asking us just to generalize what we're finding here, which is exactly what we just said. So the general idea is that cosine of theta will be the x value, or this part of your graph. Yes, you're right. It is the x part of the graph, right there. And the sine of theta is going to be the y part of your coordinate. So the big idea is that sine is always going to be the height, and cosine is always going to be the width, x, or I'm sorry, I have that backwards, y, and x. So that's our bigger idea. What you're going to move on to from here, so I was just looking at 45, 46, and 47 because they're just different ways of thinking about the same concept. In the next part, we're going to look at 48 and 49 and 50, where we'll get onto that green page.